When making observations, some astronomers see things that they have difficulty explaining. When observing distant galaxies located in distant clusters, astronomers observe a mysterious phenomenon.
The Butcher-Oemler Effect.
This observation concerns the comparison of the ratio of young, blue, star-forming galaxies to old, red galaxies in clusters that are different distances from us.
In a world where the helpless astronomer's thirst for answers can never be quenched, through tireless research, one man seeks the truth.
I'm Daniel McIntosh. I'm a senior postdoc here at UMass.
Astronomer Dan McIntosh explains more about the effect.
It's an observational effect in that clusters of galaxies that are further away or at higher redshift have a higher fraction of bright blue galaxies relative to clusters that are nearby in the universe or at redshift 0. And that trend with the number or the fraction of blue galaxies goes up as you go out in distance or up in redshift.
But is there one catch-all explanation for this theory?
No.
The problem is that astronomers cannot agree on a consistent, cohesive explanation for why this occurs. Some say the effect can be explained by the different makeup of clusters in the early universe.
As we look further away, we are actually looking further back in time. We are seeing the distant clusters as they appeared billions of years ago, because it took the light that long to cover the distant expanse between the cluster and our eyes on Earth. Astronomers use this to examine the makeup of clusters in the early universe and compare them to younger clusters.
If you just take all the galaxies in a given big volume of the universe, let's say that are all the same mass, there are more blue galaxies than red galaxies in the past and compared to today. Actually now, in today's universe, the galaxy population by weight or by mass is being dominated by the big red galaxies. Not by number, but by mass. It seems like all the mass is winding up in these red galaxies. And in the past, even, say, half the age of the universe ago, it was not that way. It was more blue galaxies. And you go way back to the early universe, we think that all galaxies started off as blue and as disks.
This could explain why more distant clusters had more blue galaxies, because there were more.
Another explanation is that the abundance of new blue galaxies can be accounted for by the rate at which the new galaxies were falling into clusters from the empty space around them. This would mean most of the new galaxies would be on the outskirts of the clusters, while the old red galaxies would be more towards the center.
The infall of galaxies must happen at some level, and clusters at higher redshift or further back in time, earlier in the universe, could have more young galaxies from the field falling in just because those clusters are forming more rapidly or are not quite done with building themselves up.
But are astronomers even sure that this effect is evidence for a particular phenomenon?
There's some controversy whether or not the effect is real. In other words, are you comparing clusters at high redshift that are different than clusters at low redshift?
Another issue is that it is difficult to see which galaxies are actually in the clusters that you are observing. When you look at a specific distant cluster, there may be other galaxies that do not belong that are blocking your field of view.
So you're really looking at galaxies in a big tube, and some of them belong to the cluster for sure, some of them don't.
When measuring redshifts, astronomers are really measuring the velocities of galaxies within the clusters. Astronomers can tell how far away the galaxies in clusters are by using these velocities. However, it can be hard to measure the velocities of these galaxies, and so astronomers might think a galaxy is part of a cluster when it really is not. So galaxies that do not really belong in the cluster might have the same velocities as galaxies within the cluster. Dan McIntosh explains.
And so here's your center of your cluster. One galaxy might be right in front of you flying towards the cluster and actually be much more in front of us or much more behind us, but because of its relative motion, look like it's at the cluster.
In a world where helpless astronomers grasp for answers to impossible questions,
they still hope that someday we can develop the technology to answer them. As technology improves and astronomers are able to see the distant clusters with a more focused eye, they will be able to further unearth the true cause of the Butcher-Oemler Effect, or reveal it for the sham that it is.
astronomers are still at the mercy of the vast expanse that foils their desperate attempts to understand the mysteries of the universe.